So, today we will discuss about the basic tools and apparatus in laboratory. So, basically concept covered in this lecture will be basically we will discuss about the nut, bolts, screws and their drivers, then soldering irons, then meter scale, slide calipers, screw gauge, magnifying glass, how these tools are used for measuring length. So, that we will discuss in this lecture. So, if you go to lab and then you will find out different types of nuts, bolts, washers, screws, nails and their drivers, means to screws or to bolts this. So, what are the instruments are required to do the job. So, these are basically is called these ranges, then Allen keys, then screwdrivers. Okay. So, just I want to make you familiar with these tools. So, this basically this from my lab, this whatever I am showing here, this is from my lab. So, I have also brought these items to show you online. So, so let us see one by one. Say this one type of screw. If you see this these are screws. Okay. So, this very small screws. We have bigger also. Say another types. This is different. So, this one I think I have to bring out. This basically screws. Okay. Now, what is the difference between screws and bolt? So, that I will tell you. Then I have you see this is another type. So, there are various kind of nut, bolts, screws we use in lab. This basically nuts. Okay. So, this whatever I have shown in picture, so all from my lab, and that is what I showed some of them to you. Now, just let me tell you about the difference of these words: nut, bolts, then screws, nails. Okay. So, here if you see in this picture, so you see I think these are basically, here we have bolt, these are nut, these are nut, and this is the washer, okay. So, I think I can use pointer. So, these are washer, whether I think that will not. So, this is the washer, this is the bolt and this is the nut, right. So, there is a washer of various kind of washers are here, nuts are here, and these are basically all are bolts, these are bolts, and these are screws. You see difference between the bolts and screws, all are threaded, both of them are threaded, but difference is that this edge of this one and this is sharp. So, it can penetrate if you put in wood or some soft metal. So, it can penetrate into that. So that's why it is different from this bolt. Bolt, this end is flat. Bolt, this end is flat. Okay. So so this is the difference between the screws and bolts. And nut, of course, these are the nuts. And nail, these are the nail. Nail, you know this generally. In house also you use for this carpenter, they use this nails. So there is no thread in these nails, and this edge is sharp. Okay. So using hammer generally we can put these nails into wood. Okay. So these bolts, again there are various kind. You see, if you see the edge of this bolt, head of these bolts, you see this header is hex, it's called hex bolt, and these heads are is different than this one. These also hex. Now to you need different tools for these two type of heads, so that I will show different drivers for this to deal with these different heads of the bolts, and of course screws also. So there are different kind of here. I have shown different types of tools, these drivers basically. So screwdriver, these are screwdriver. Here I have set this screwdriver. Okay, here you can see this is the screwdriver. Okay, now screwdriver, this end is different. It's some are flat, some are star kind of things. Okay, so for different type of head we need different type of end of this screwdrivers. And this head is generally, sometimes people tell the jewelry screwdriver. So another type of screwdrivers are there. So this very frequently it is used, here you see this is a star kind of edge, and this are different. So to take out the nail, okay, so one can use this screwdriver. So some are you have flat edge. Okay, flat edge. So for different head, basically you need different type of screwdriver. So these are the common tools for laboratory. One should at least you should know the name and what are the things available, and so you can demand for when you need to use, you can demand this kind of tools in the laboratory. So these are range, various kind of range also, whatever I have shown in picture. So it's basically it's for my lab. So we frequently use this range. You see, this all are basically for of different sizes of bolt. Okay, this head, as well as this for you see where you are putting them. So depending on the geometry of that place, so whether you will use this one or that one, so that also another factor. So I think if you know this type of instruments are available, so so this use of them you will see in our lab also. When we will demonstrate some experiment, sometimes we will use some of them. Okay, so these are the basic tools for the laboratory, and you should know the name of them, and slowly you should try to use of them also. So just I will show one use of them to you. So here, say I have a I think this another box can you give me. So I have one capacitor and this yes. So I will show you one piece of you see, if you see this one, okay, So this is a so there are many small pieces are there, okay, and this here also we have used this bolts. Sometimes bolts and screws we confused, okay. So if smaller bolts, so then we generally we tell screw. So this we tell generally screw, but it's in principle it should we should call it bolt, because its edge is not end edge is not sharp. So if you want to open this one, so you have to choose proper right the screwdriver, okay. You have to use right screwdriver. So I need flat one and smaller one also. So if you want to open this piece, so just I think this is the right one, so I can use it. Yes, I can use this. Now when you will use, you see I will not open one screw first. There are two screws, okay. I will not open the one first and then the second one. It is not that. So both simultaneously I should open, okay. So I think this I can separate these pieces, okay. Now this piece I have taken out. So this this is the screw, okay. See, it's small, so that's why we are telling screw, but we can tell also bolt. So this is the piece we attached with this using this screw. So this is the use of screwdriver and this the screws, okay. So this just I showed you where we use of these tools. So later on, what is the use of this one? So I will explain to you. So right now I think this was some physics behind that one. So it is related with some experiments, so that I will discuss later on when I need. So I will proceed with this basic tools and apparatus at the moment. So then if I go next tools, so that is basically very important for the lab, that is what is called soldering iron, right. So you have seen this soldering iron in lab, so you have to know how to use it. So at least you should know the name of the different parts. So here you can see this is called iron, okay. This is called iron, this called solder, okay, and this is this sponge kind of things. It's a we tell wet sponge, okay, and this is the rosin flux. So these the four main items. This is a set of soldering iron. So so if you I can show you. So this is also again from my lab. It is again from my lab, okay. So it looks very dirty, but because we are using them. So this is the rosin flux, and I have different colors of this soft sponge, okay. So this soft sponge, basically if you look at this edge of the iron, so is very dirty generally, okay. So generally, so I will not heat here. So later on probably we will use it and you will see how to use it. So basically first we have to clean this edge, okay, and this after, so you have to plug in, and then after becoming hot this edge, so we just paste with the crash with this wet sponge, and then it will be cleaned, okay. So after cleaning, now you want to solder. Where is that solder? That I think Oh, it is here. Okay. So it's a solder. This is the solder. It's basically wire. It's the wire of earlier people used to use lead. So it's a tin lead, or nowadays is a tin silver. This is the alloy. Okay, the soft melting point. So so when we will solder, so we say solder uh, some wire with I can show you. Say you want to solder these two pieces. Say these two pieces you want to solder. So these two pieces you have to hold. Okay, you can hold with some instrument. Okay, you can hold some instrument. So now actually you have to, so so this should be hold. Okay, so I think this, say two resistance I want to solder it, I want to connect them. So this way then you can hold it, you twist it first, and then so what we do, so this wire, so what we do this just two ways. Either you can take uh, this solder material on tip of this iron, and then you can put here. So other way, so you can heat this wire, and if you touch this solder wire, so this wire will be melted and put on this. Okay. Now what is the use of this resin, rosin flux? This basically, we if it is oxidized. Okay, sometimes these two wire you have taken, so they are oxidized. So if you want to, so you have to remove this oxide part. So there we apply this resin, and then we heat it using the iron, and then this rosin basically it will take out this oxide from this wire, and after that, okay, then you can again solder it, okay, using this solder wire. As I told, just heat this wire and touch with this solder wire. Okay, solder wire will be melted and put on it. Okay, so it will then you will get the good contact of these two, say here, two resistance. So this is the use of the solder, and probably later on you will see how we are going to use, but at least you should be familiar with this type of tools. In laboratory generally frequently we use. Okay, and this stand also important because it's you cannot keep it on top of table or wooden table, or on paper. So when it is hot, so you have to keep here, so it is in safe position. So this, because of this stand also important. Okay, so this is the basically introduction about the soldering iron, and it is very useful in the laboratory. Generally our students don't use much, we don't allow them to use because one has to take precaution because it is hot. So but you need proper training to use it, and you should use because if you, because these are the basic apparatus, and you should not have any inertia in using of them. If you are become familiar with these basic tools, and if you are trained to use them, so in future it will help you to take any project kind of things where you can think of designing a new kind of experiment, new kind of apparatus. So, if you think to design, you see, one is ready-made instrument, somebody is preparing for you, everything ready, you are going and taking data, that is what you are doing, most of us we are doing. But here in this course I will try to convince you this to perform the experiment in other way, in different way, so that you should not have any reservation, any inertia to take project, new kind of project. Okay. So, next important tools or apparatus in the laboratory, very simple one. So, that is the meter scale. Okay. So, meter scale also frequently we use in laboratory, but this now why I am showing you, why I am telling, because measuring length in laboratory is the essential part, is a essential part of many experiment. So, you should know how to use the scale, how to use the scale to measure the length accurately. Okay. Also here I will discuss about the significant digit when you are recording the reading. So, what is the significant digit, what is the doubtful digit, okay, doubtful figure. So, that I will discuss in this scale, in this case. So, whenever you are going to measure a length, so you need tools. So, this meter scale is a very common tools. Other tools are there, so that is slide calipers and screw gauge. So, I will discuss now about these three tools, okay, how to use for measuring length. Say you have to measure, say you have to measure one measure the volume of a rectangular or a regular shape item. Okay. So, I can show you here. So, I think, yeah, say if I ask you, you find out the volume of this rectangular box, okay, or you find out the volume of this square shape body, or this rectangular shape another piece of body. Okay. If I ask you to find out the volume of one of them, okay. So, what you will do? So, you will take the meter scale, I think I have meter scale, same meter scale as I have shown you in the picture. Okay. It is not good one, but you can use it. So, here basically in meter scale it has two scale in centimeter, one scale, and another scale in inch. Okay. So, we will use this centimeter scale, right. So, now if I want to find out the volume of this box, so this rectangular box, so you know this volume is equal to basically the length into breadth into thickness, right, into thickness. Okay. So, basically I have to measure the length, I have to measure the breadth, and then I have to measure the thickness, right. So, here this is the bigger one. Okay. So, I can use this centimeter scale, meter scale. So, now to start measuring this one, so first one has to do for you have to find out the least count of this scale, okay, of this scale. So, least count obviously of this scale, you can in picture you can see here, least count of the scale is basically, see, this is the 20 and this is the 21. So, in between there are 10 divisions. So, this is 1 centimeter, and in that 10 divisions are there. So, one division is basically, each this line is basically each division is 1 millimeter. So, this least count of this scale of this tool is basically this 1 millimeter, right. So, that you have to first note down, and then you have to measure. Second important thing is you have to measure the length. Okay. So, then you one side I will this 0, this side is I set at 0, and the other side some readings are there. So, you have to take reading. Now, remember that whenever you do experiment, then we tell, always we tell, you should take not only one reading, you should take more than one reading and then take average, right. Why? Now you have to think why we should take more times the reading, what is the necessary of that one. So, that you have to understand. So, now you will take 2 times or 5 times or 4 times or 3 times. So, that you have to decide. So, generally we tell student, okay, you take 3 times. Okay, this is the routine wise we tell, but this is not the way to tell, or this is not the way to do it. So, whether in this case now you tell me that whether I will take 3 times or 2 times or 5 times. So, there should be reason behind it, how many times I am taking. Okay. So, here I will tell you to take 4 times. Length measurement you take 4 times. Why? So, there are 4 edges, you see, length, this one edge, this is another edge, this is the third edge, this is the fourth edge. Okay. So, I can tell you that edge wise in 4 there are 4 edges. So, you take the length in along the edge. So, there are 4 edges. So, you take the 4 times, you take this reading 4 times. Breadth also you take the 4 times, because there are 4 edge. So, this I say I am taking 4 times reading, and then I will take average of these 4. So, why not 5, why not 3? It is 4, because there are 4 edges. Okay. So, it is and why we are taking 4 times 1 edge. So, there are some maybe that this length of this length may be different. Okay. So, it may not be perfectly rectangular. Okay. So, that is why we should take average of this 4 edges. So, that is why we are taking 4 times, same reading 4 times. Okay. And if you take a wire, say you are measuring the thickness, not thickness, radius or diameter of the wire, then we tell that you take few times. Why? Because this wire diameter along the length, it may not be same. Okay. So, we should take the average. So, that is why we take 3 or 5 times at different position, depending the length of the wire. Okay. So, you have to take this side. So, it is compulsory that you should take few times this reading. Now, how many times you will take? So, you have to decide. It is not that teacher will tell so 5 times you should take. So, for all experiment you are taking 5 times. So, this should not be the things. It is, there should be reason why you are taking 3 times or 5 times or 4 times. So, as for example, as I told you here in this rectangular box, we are taking 4 times reading, because there are 4 edges. Okay. So, that way you have to justify why you are taking few times the same reading. So, that you have to justify. Okay. So, if I will take say along the 4 edges, along the 4 breadth, along the 4 edge of the thickness. Okay. Here you can see these 4 edges of thickness. Okay, I will take. So, if I measure, so I will show I have measured not this box, but for another block. So, I will show how to take the reading and write them and then analyze. Okay. So, if you see it here, see here say experiment using this meter scale, find out the volume of a solid of regular shape. So, I have say, so for that apparatus you need meter scale and a say rectangular block. Okay. So, first as I told that you have to find the least count of the meter scale. Okay. So, that is 0.1 millimeter means 0.1 centimeter. Okay. Now, you have to measure the length, breadth and thickness. So, you can make a table. Okay. And in that table what should be the column, this number of observation, and then length, what is the unit in centimeter. Then you are taking 4 times as you have decided or as I told. Okay. So, so 4 times we will take this reading in for length, and then we have to take average length, find out average length. So, this is the average length I will explain, and then breadth reading you have taken in centimeter, thickness reading you have taken in centimeter. Okay. Now, 4 reading I have taken. Okay. So, here first reading for length, say if I explain one, so other will be similar. So, here I have written first observation 7.90 centimeter. Okay. Then next one I have written 7.92, third one 7.92 and then 7.93. Okay. Now, here question is that least count is 0.1 centimeter. So, whether I should write 7.9 or 7.90, both are same. Is it both are same? Reading wise this same, but you see error it has significant, this digit has significant. So, 7.9 and 7.90 are not same. When you are writing 7.90, you are demanding basically the accuracy up to this last digit. You are demanding accuracy up to 0.01 centimeter, but your least count is 0.1 centimeter. So, you should not write 0, you should write 7.9, but you can write 7.90 and then naturally up to second digit decimal you can write. So, then this last digit, this second digit, after decimal second digit, this called doubtful figure, doubtful figure. Okay. So, you are writing up to second digit. So, then 7.9 is the accuracy, it has accuracy 100%, and then 0 this is doubtful, because in meter scale you know, in meter scale here you can see this between these two line it is a 1 millimeter, but you have scope to guess that if this some reading is between these two line. So, you can guess it is 50%, it is in middle, or it is slightly left to the middle or slightly right to the middle. So, you can guess 1 millimeter, even you can divide it into 10 division. Okay. So, then you can guess, okay, it is 0.02, 0.05, okay, 0.07. So, that type of guess you can do, but it's not accurate one, it is the doubtful digit. So, that's why here up to second digit I have written. Then this digit generally we write in bracket, this digit we write in bracket to show that, to tell that these are doubtful digit, but this reading 7.9, this is the accurate reading as per least count of these tools, and this second digit we guess this digit, this in this measurement, and this is the doubtful digit. Okay. So, doubtful digit, either we have to mention, either it is a bold letter or it is in a bracket. You have to tell there is accuracy up to first digit after decimal, second digit we can, this is the guess reading, and it is a doubtful digit. Okay, fine. So, now second part is the calculation. Okay. So, you have to find out the average length. average length. So, if you add them, so it is 7.9, it is there in all is 7.9, it will be there. Now, here this second digit, so 322 and 7. So, if we divide it by this 4, okay, 0.07 divide by 4, then you will get 175, right, 7.9175. So, if you use calculator will give you 7.9175. Okay. Now, question is whether you will write this one. Now, again if you write this one, that means in length measurement you are demanding this accuracy up to 4th decimal, up to 4th decimal you are demanding, means 0.0001. So, that is the accuracy least count of your instrument. So, but this is not the case. So, here I can write 7.9 and then 2, here 1 is there. Okay. So, following so 1 is followed by 7. So, if it is 5 or more than 5, generally we increase by 1. Okay. If it is less than 5, then just we leave it. So, here one can write 7.9 2. Now, 2 in bracket I have put this the doubtful digit, as my instrument's accuracy is 0.1 centimeter. So, this second digit, second figure will be doubtful figure. So, you cannot write this one, okay. Either you have to write this or you have to write this, okay, 7.9. Similarly, for this breadth also one can calculate. So, this is the, so from this measurement actually I am trying to tell you the importance of the least count. I am trying to tell you the how to write the after calculation, okay, after multiplication, after average, after division, whatever result you will get. So, up to which the figure it is significant, which figure, which digit is doubtful. So, that one has to understand, and that's what I have taken this example. Now, you have to find out the volume. Okay. So, now you have to multiply this length, breadth and thickness. So, here 7.92, right, here 7.92 and here 5.01. So, 5.01 if you multiply, so you are getting 39.672, okay, 6792. So, again you have to think that whether I should write this one, after multiplying this one, these two, and then I will multiply with the third one. So, here again you have to follow some rules. I will tell you that you can keep up to 3 figures from the left. You can keep up to 3 figures, because why 3 figures? This whatever these 2 you have to multiply these 2 numbers. So, what is the you have to see the smaller figures of these 2 numbers. So, this basically smaller figures, how many figures are there, how many digits are there, 1, 2, 3. Okay. So, if one of them is having the 2 digits, so these smaller figures will be 2. So, here after multiplication you can keep up to these 2 digits. So, here since it is 3, so you can keep 3. So, I have kept 39.6. Now, 6 is followed by 7. So, it should be in principle 39.7. So, by here I have taken 39.6, but it should be 39.7. So, now I will multiply with this 1.52, right. I will multiply with this 1.52, this thickness. Okay, if you multiply with this 1.52 with 339.7 in principle, but I have multiplied with 6 by mistake, it should be 0.7. So, if you multiply, then it is coming again 60.192. Okay, the result is coming 60.192. Here again these two digits you have multiplied. So, here minimum smaller figures are these basically. Smaller figures means how many digits are there. So, basically 3 digits again. Okay, 3 digits 1 2 3. Okay. So, here from the left you have to keep up to 3 digits. Okay, 1 2 this 3 digit. So, 60.1, this reading will be 60.1, 1 is followed by 9. Okay. So, this 60.2. So, this, and again since you have taken this last digit is doubtful digit. Okay, doubtful digit. So, in results also whatever 3 you are keeping, so last word is the doubtful digit. So, your result is basically 60.2, 60.1 and followed by 9. So, it is increased by 2. So, 60.2 cm cube. Okay. So, here this 2 is again its doubtful digit. Okay. So, you have to keep in bracket. Actually accurate this you can demand the 60 cm cube. Now, 60.2 you can demand, but you have to tell this last digit is doubtful digit. Okay. So, so basically through this example we are learning how to, what is the significant digit, what is the doubtful digit, and how to find out. So, rules are just I will tell you. The rules are the significant digit, doubtful digit. Rules is in all average keep but one doubtful figure. You can keep one doubtful figure. So, if the figure following the doubtful one is 5 or greater than 5, increase the doubtful figure by 1. Then second rule is after multiplying two numbers together, keep in the result as many figures of the product counting from the left as there are figures in the smaller factors. The two numbers you have multiplied. So, this they are factors, right. So, what is the smaller factors? So, in the smaller factor what are the figures that you have to find out, and then after that, after dividing one number by another, keep in the quotient counting from left as many figure as there are in the smaller of the two. Okay. So, whatever I told you, so these are rule. Okay. So, following this rule one can write the significant digit and doubtful digit. So, I think I will stop here. We will continue discussion next class. Thank you very much.